Bismillahirrahmanirrahim. Good morning, distinguished guests and college. My name is Ulhaq Nadila. It is an honor to present our research on comparative analysis of flexural strengthening for reinforced concrete beam using single and double lines of FRP plates. This study was conducted under the supervision of Dr. Arya Wangunadi MT at Bandung State Polytechnic. I will begin by introducing the object and background of our research. The first introductions fiber reinforcement polymer or FRP has become a crucial material in enhance the performance and durability of civil infrastructure. There are various types of FRP fiber, including aramid FRP, glass GFRP, bamboo BFRP, carbon CFRP, and natural fiber and FRP, each offering different degrees of resistance depending on environmental factors. FRP reinforcement has shown to increase flexural capacity by 20 to 100% based on the type of fiber used and the condition of the concrete substrate. However, despite its advanced, challenges remain, particularly with carbon fiber reinforced polymers (CFRP), where used such as the plate and debonding and mine flexural crack limit its effectiveness. These challenges from the focus of our research as we aim to optimize a technique and improve the long-term durability of FRP reinforced structure. Previous studies have consistently demonstrated the mechanical benefit of using FRP material to strengthen concrete structure. However, specific challenges, especially with FRP such as the bonding at the plates and the mine flexural cracking, often hinder its full potential. To mistake these issues, advanced methods like near surface methods (NMS) and extrudely bound reinforcement (ABR) technique have been investigated. The literature underscored the need for improving bonding technique and refining installation method to ensure the long-term effectiveness of FRP in civil engineering applications. This study, we conduct tests on three reinforced concrete beam specimens. The first, a control beam or CB, a single line FRP beam or FB1 line, and a double line FRP beam FB2 line. Each beam had dimension of 250 millimeters by 300 millimeters by 3000 millimeters and was subject to a monotonic two-point loading test. The AP1 line specimen was reinforced with a single layer of FRP, while AP2 line employed a double layer configurations. Our focus was on evaluating the first crack load, maximum load, capacity load, deflection, ductility, and less, following the guideline of SNI 4431:2011. Finding and discussions. The result of our study is as follow. AP1 line beam exhibit a 40.85% increase in the first crack load compared to the control specimen or CB. However, it also demonstrated an 11.42% reduction in maximum load capacity. In contrast, the FB2 line, AB show a substantial improvement with a 126.05% increase in first crack load and a 10.90% rise in maximum load capacity. Nevertheless, it experiments a significant reduction in ductility by approximately 52.01%. In terms of failure modes, we observe addition, failure, and delamination the FB1 line specimen, while the FB2 line being performed better in load capacity, but at the cost of reduced ductility. This finding highlight the importance of proper surface preparations to enhance bonding and reduce the risk of debonding in FRP reinforced structure. At last, in conclusion, our study found that double-line FRP reinforcement AB2 line provides superior load-bearing capacity compared to single-line reinforced FB1 line. However, the use of the bonding, particularly with the single-layer reinforcement, remained a significant challenge. Our results suggest that optimizing surface preparation technique and layering of CFRP can take these risks, ultimately enhance the structural performance and durability of FRP reinforced beam. Future research shall be focused on refining this application technique to address this challenge effectively. These are the primary references that have support our research, including recent studies on the mechanical properties of FRP composite flexural straightening using virus fiber type and the application of FRP in civil infrastructure. This work have contributed significantly to the foundation of our study. Thank you your the time and attention. I will now be happy to address any question or engage in future discussion on this topic.